Hello, we're going to go over Statistics, Chapter 4, Section 4.3. I've given you a little preview in the previous video, but here's where we're going to talk about regression line. So the equation of the regression line is basically a predicted line of what's going on. If we use the format y equals ax plus b, a would be representing our slope. Remember, our slope is in front of the x, and it tells us how it's changing. The b would be representing the y-intercept. And we've already talked about below how to get there. Stat, calculate, by hitting to the right, number 4 for linear regression, and make sure your diagnostic is turned on. And when you do that, the r squared is that coefficient of determination, the percent of the data explained by the line. So we're going to be practicing this going back to our manatee data. So remember, our manatee data is in list 1 and list 2. So if I go back here, this was our previous example, hit clear. I'm going to go to Stat, Edit. We're going to be using our manatee data. Remember, list 1 is number of powerboat registrations. List 2 is number of manatees killed. When I go to y equals, clear the previous equation, starting from scratch. When I hit second y equals, we'll be going back to plot 1, turning it on, choosing scatter plot. This time x is list 1 for number of powerboat registrations, y is list 2, number of manatees killed, and we're going to go back and change the window as we did before. We went from 400 to 750, counting by 50s. We went from 0 to 60, counting by 10s. So let's just hit graph. This was our scatter plot. Remember, in review, it's linear, positive, which means the more powerboats you register, the more manatees are killed, and it looks like a strong relationship. Now, if we want to get the line that goes through the data, we're going to go through these steps. So we hit Stat, Calculate, number 4. You could also use number 8, but remember there's a little difference there. List 1, comma, list 2. And if you had the other one, you do list 1, list 2, and then hit enter. And then we get all information, correlation, coefficient determination, and then here's our slope, here's our y-intercept. So A is our slope, 0.125, let's say. B is our y-intercept, negative 41.43. Now if I want to see the line, remember those numbers, we go to y equals 0.125 x minus, subtraction, 41.43. And if we did this correctly, when I hit graph, the line goes through the data. Remember, your calculator is taking all the dots, all the data, and find the line that's the least squares regression, least distance from every line. And then the most important part is, what does this mean? Remember, slope is output over input. So if we go and explain the most important part of this, the input was number of powerboats registered. Our output is number of manatees killed. So when I look at the slope, the top number is output, number of manatees killed. The bottom number is number of powerboats registered. So one way to explain this is every 1,000 powerboats registered, 0.125 manatees are killed. Perfect explanation. But if you want a little more understanding, if we move the decimal over 1, as long as you move the other one over 1, we could also say, same number, 1.25 over 10. So every 10,000 powerboats registered, 1.25 manatees are killed. Every 10,000 powerboats registered, 1.25 manatees are killed. So not only can we say there's a positive, linear, strong relationship, we can't say one caused the other one based on correlation, but based on the data, every 10,000 powerboats that Florida registers, 1.25 manatees are killed. Now, the y-intercept sometimes doesn't make sense or sometimes does. It really depends on the problem. But remember, to explain a y-intercept, it's when x is 0. It's when x is 0. So x is number of powerboats registered. So at 0 powerboats registered, negative 41.43 manatees are killed. Now, does that mean if we stop registering powerboats that 41 manatees are going to come back from the dead? No. But it does have some meaning, saying that there's no powerboats registered, no manatees would be killed, And the reason for the negative is it's not going to happen. There's a lot of water out there with one powerboat or even 1,000 powerboats. It takes 10,000 powerboats for that 1.25 manatees to be killed. So there is some meaning here. But again, how do you explain slope? Output over input. How do you explain the y-intercept? It's when x is 0. When x is 0. So we have an example here. We'll use this as a review example. We'll start from scratch. So first of all, we read the information. It says the round-trip airfares from Boston. We have different cities here. We have cost and we have miles. So does the cost determine the miles or the miles determine the cost? So in this example, I'm going to make miles x, my input, my explanatory. I'm going to make the output y, my cost. Then, still not touching the calculator, but miles, we need to make a window. The lowest is 206. The highest is 3,095. So maybe from 0 to 3,500, counting by 500s, or 0 to 4,000, counting by thousands. Again, you decide based on the data. My cost, the lowest is 99. The highest is 443. So maybe 0 to 500, counting by hundreds. But you decide that first. Then we go to the calculator. Now, we're using our calculator a lot. So to make sure we have a clean calculator, we hit clear, clear, go to y equals, remove the y1, and let's put the data in the calculator. We can leave that plot on because we're going to change it. And we definitely have to change our window. So we go to stat, edit. I put this data in list 5, your miles, remember that, list 5, miles, and your cost in list 6. Okay, so step 1, put the data in the calculator. Step 2, second y equals, turn plot 1 on, but this time, still scatter plot. X is list 5, second 5, y is list 6, second 6. Again, you can decide if you want it to be a box, a plus, or a dot, your choice. I like the box. Move it up, up, up. Hit graph. Nope. Hit window. Don't hit graph yet, because remember, that's the other window from the previous problem. So we hit window. I'm going to go from 0 to 3,500, counting by 500s. And you would draw all this out. For money, I'm going to go from 0 to 500, counting by hundreds. Again, you decide what works best for you. Hit graph. We can see all of our data. Review. We have a positive linear relationship, not as strong as the rest, the dots aren't as close, but a linear, positive, stronger relationship. So that's number 1. Then if we hit stat, to the right for calculate, linear regression. Again, if you have the other calculators, put list 5 and list 6. This version, we hit list 5, comma, list 6. The correlation, positive, still strong, closer to positive 1 than into 0. But not as strong as the previous examples. R squared, percent of data explained by the line. There's your slope. There's your y-intercept. A goes in for A. B goes in for B. Round appropriately. I'm going to do 0.08 and then 162.60, which I write down here. To make sure I did it correctly, go to y equals 0.08x plus 162.60. Enter. Graph, line goes through the data, and then the most important, what does this all mean? That's the real part I really want to stress here. So in this case, the slope is 0.08 over 1, output over input, very important. So every 1 mile cost 8 cents. The y-intercept is when x is 0, so at 0 miles, 0 miles, little error here, at 0 miles, that should be 0 miles, the cost is 162.60. At 0 miles, the cost is 162.60. Does that mean, based on correlation, miles causes cost? No. Remember, correlation doesn't imply causation. Correlation doesn't imply causation. Okay? Example, then practice, practice, practice.